The other day, I decided to order in from two different restaurants. I just gotten my COVID relief check, so why not spend that to stimulate the economy and my stomach? I sent an order to both Subway and Jimmy John's, which was supposed to read, I want some sandwiches, period. In my haste though, I actually sent the message, I want some sand, period, witches. Subway sent me a text saying, there was an error in your order, please try again. So I reordered and got my sandwich about 20 minutes later. Jimmy John's sent no such error message, so I assumed everything was a-okay. But later that day, I received, you guessed it, a big pail of sand. So why did these two restaurants respond so differently to my typo? That's precisely the topic of my thesis. I study a cellular process called nonsense-mediated decay, or NMD. This is basically the cell's way of performing a spell check. When the nucleus wants something, like a sandwich, it writes a message to the cell. This message is called mRNA, and it functions similar to your order at a restaurant. But sometimes the nucleus will make a mistake, just like I did. NMD is a way for the cell to know that it should be making sandwiches, not sand. So how does NMD work? How does the cell know there's a typo? It looks at what comes after the message's punctuation. Every mRNA has a stop codon, which is like the period at the end of a sentence. But if you read a sentence and see more letters or words after the period, you think that's a bit strange. The cell does too. It flags these messages with an error and sends them to the shredder, just like Subway did with my order. My thesis aims to understand how different types of cells notice these typos to a different extent, and how that may explain why some cells make sandwiches and others make sand. My primary experiments use a specific chemical to turn off NMD in these different types of cells, and then I observe their responses. I found that most types of cells, like skin or kidney cells, are pretty good at recognizing messages with an early stop codon. Neurons, the cells that control our thoughts and movements, are more like Jimmy John's and do not realize there's an error. By investigating the efficiency of NMD across these different types of cells, I will be able to understand why some are so susceptible to the loss of the spell check function, as is the case with neurons in forms of neurodegeneration like Lou Gehrig's disease. Ultimately, we will be able to develop therapies that are targeted to the specific biology of neurons to help treat patients who are living with Lou Gehrig's disease.